Welcome, physical science students in Tolbert's class. This is the sustained silent reading, chapter 7, section 3. This here will probably be page 189 from your book. So, let's look at what we have here. The 7.3, conservation and forms of energy. What happens? What happens when you throw a ball straight up in the air? Figure 7.11. The ball leaves your hand with kinetic energy it gained while your hand accelerated it from rest. As the ball goes higher, it gains potential energy. However, the ball slows down as it rises, so its kinetic energy decreases. The increase in potential energy is exactly equal to the decrease in kinetic energy. The kinetic energy converts into potential energy, and the ball's total energy stays the same. So that's talking about this little picture right over here. When you throw a ball up from your hand, as it goes up here, it gains potential energy, and it starts to lose kinetic energy as it slows. Then as it rounds that corner, comes all the way back down. It gains more potential energy, it gains more kinetic energy, and the opposite happens to its potential. So, the law of conservation of energy. The idea that energy transforms from one form into another without a change in the total amount is called the law of conservation of energy. The law states that energy can never be created nor destroyed, just transformed from one form to another. The law of conservation of energy is one of the most important laws in physics. And here it is, restated one more time. Energy can never be created nor destroyed. Using energy conservation. The law of conservation of energy explains how a ball's launch speed affects its motion. As the ball in figure 7.11 moves upward, it slows down and loses kinetic energy. Eventually, it reaches a point where all the kinetic energy has been converted into potential energy. The ball has moved as high as it will go, and its upward speed has been reduced to zero. If the ball has been launched with a greater speed, it would have started with more kinetic energy. It would have to climb higher for all the kinetic energy to be converted into potential energy. If the exact launch speed was given, the law of conservation of energy can be used to predict the height the ball reaches. Energy converts from kinetic to potential. The ball's energy conversion, energy on the way down is the opposite what it was on the way up. As the ball falls, its speed increases and its height decreases. The potential energy decreases as it converts into kinetic energy. If gravity is the only force acting on the ball, it returns to your hand with exactly the same speed and kinetic energy it started with, except now it moves in the opposite direction. Alright, this will be the top of the page 190. I won't be covering the solving problems, but I'll just be reading the how to use energy conversion. How to use energy conversion easily. Energy conversion is a direct way to find out what happens before and after the change from one form of energy to another. Figure 7.12. The law of conservation of energy says the total energy before the change equals the total energy after it. In many cases, with falling objects for instance, you need not worry about the force or acceleration. Applying energy conservation allows you to find speeds and heights easily. So this picture here demonstrates the law of conservation of energy. So the total energy before the change is going to be equal to the total energy after the change. Alright, so that was the sustained silent reading for 2 pages. You can notice the problem solving for how to solve problems for the conservation of energy. We've covered a little bit of this in class. In this particular case, if you get a 2 kilogram car moving at 2 meters per second, this was actually one of the sample problems that was done in class. Hopefully you took the time to write this down. Alright, have a good day, and I will see you in the next sustained silent reading, which is on page 191.